Great.
That's strange. I see myself in mirror image.
Yes, I have the same. And then you're like, is it me? Very strange indeed. Philip, just to confirm, can you see my screen?
I see white behind you, only white.
Wall.
Yeah, the wall.
I have some windows here as well, just saying. Yes. Okay, 1 more minute. We have some people are joining. We're using a new platform from European Commission, so we're learning all the time this new platform with every session, if everything is working well.
All right.
Yeah.
How many people do you expect?
It really varies because it's a 4 days event, so it's always something between 20, 30 to around 60, 70.
Okay, we'll just see.
So we're of course we're looking forward to meet as many people as possible, especially that we're having this exciting training. And we have 2 days, so we're really glad to have you as well as a starting.
Great.
Yeah. Okay, I think it's free, so we can start. So welcome everyone at the Ethics by Design session. This session will have 2 parts. So firstly, we're going to have an interview with our fantastic guest Philip Bray, and secondly, we'll have my colleague Martin Dahiver from DMU will take over and engage you in an Ethics by Design training session. So let's start with the beginning, so with the first part of an interview. Let me tell you why did we organize this session. So basically, PHET is about developing radically new research lines, alliance of technology through unexplored collaboration between advanced multidisciplinary science and cutting-edge engineering. And we as PREFET have identified 20 top hottest PHET trends for the upcoming future for the European Commission, but also for us researchers that could explore these trends. And discussing that edge technologies include 3D printed molecules, limits of quantum computing, cellular senescence and life and extension, biorobotics, Arctic climate change, and zero-net power sensors. So all really exciting technological developments. But at the same time, this new radical technologies should actually also make a difference to society. So for this session, we want to inspire you and encourage you to look at PHET, but also your own projects from a little bit different perspective. So today we have with us Philip Bray. Let me introduce Philip to you. We're incredibly honored and happy to have you, Philip, here. So Philip is the professor of philosophy of technology at University of Twente in the Netherlands. He's also president of International Society for Ethics and Information Technology and former president of Society for Philosophy of Technology, SPT. And his expertise and research interests involve ethical aspects of emerging technologies with particular focus on information technology, robotics, biomedical technology, and environmental technologies. Additionally, he also leads currently European Union Horizon 2020 project Siena that focuses on ethical and human rights aspects of emerging technologies, including human genomics, human enhancement, robotics, and artificial intelligence. But Philip is also engaged in various other projects, such as Sherpa project that focuses on artificial intelligence. And in the past, he's been doing many different projects at the European level, but also national level in the Netherlands. And Philip is a person of many faces. So he's an amazing philosopher, an academic. He teaches students. At the same time, he also engages in advising policymakers on technological developments and looking at ethical aspects of these technologies. and at the same time, as I mentioned, he engages in these different networks, European, international, and national networks. So we're incredibly incredibly honored, Philip, and grateful that you managed to join us. Thanks so much.
Happy to be here.
So how we thought about this interview. So we prepared 4 questions for you, exactly to inspire and start the discussion about these ethical aspects of technology, and then we'll leave some time for our audience to ask you questions. Okay. So the first question that I wanted to ask you is, why should we care about ethics in future and emerging technologies, PREFET?
Okay, I'll give you 2 reasons. Society cares, and the European Commission cares. So starting with society, of course, well, future and emerging technologies are really about changing the future. They're about radical innovations that will change the economy, that will change society, that will change the way we live. And with so many changes coming from these technologies, it's very important to consider the ethical aspects. Won't they have negative implications for human rights? Will they really benefit people? Will they increase our well-being rather than reducing it? Will they contribute to a just society? So it's very important to look at that for these technologies, more so than for many others, I think, because this is also often the first time that these radical concepts are being considered, or one of the first times. So for society, I think it's very important that it happens in FET projects. I think it's also important for the European Commission because, I mean, they say it's important, right? Because, of course, all EU projects go through ethics review, so there's already that. But I've noticed that paying special attention to ethics, for example, having an ethics task or work package in your project, often is looked upon very favorably by reviewers and certainly by FET projects. So including that, it makes you seem responsible. It shows that you're aware of these ethical issues and that you want to really take some time in your project to account for them.
Yeah. And Philip, then also, is there anything that, okay, we as researchers, we should take care of it, but take care of ethics, but also why would we care for society? So through our technologies that we develop for our projects, so society cares, but we're talking also about FET, very often radically new technologies that are even very hard to imagine, and they are very hard, okay, to figure out what are potential even applications sometimes. So why would we care at this point when they are so radical and so futuristic?
Yeah, it's true what you're saying, and that's definitely a very good point. Let me say 2 things about that. First of all, ethics is actually rarely about prohibiting things. So this is a misconception that I think many in the engineering sciences have, that ethics is about saying what you cannot do, which I think is not, is 95% of the time is not true. That ethics is really about saying, how can you do the same thing that you want to do, but do it better, in a way that's more compatible with the values of society and more compatible with ethics. So I think, or to already conclude that at an early stage, and that's my second point, is actually beneficial because then you can already start guiding your research and developing it in such a way that it's more likely to be commensurable with human values, with ethics. And I think even if you're doing research that is of a more fundamental nature, that is kind of at the beginning of the scale, technological readiness skill, to already start anticipating these ethical issues in the future is something that you can do. We have methods for that, and something that then can also provide this guidance at this early stage.
Yeah. So I think that exactly this, your answer leads us to the second question. So how to apply ethical principles and values in FET?
Right. So that's not an easy question. So certainly one recommendation that I would make if you want to pay serious attention to ethics in a FET proposal is to get one or more ethicists on board, and especially, of course, ethicists who have done this kind of thing before, who are specialized in ethics of technology, basically. And I mean, they exist. We have, I think, many of them now in Europe that could be included in such a project. And I think it's important then to say, well, ethics is not just something I do at the beginning of my project when I fill out the questionnaire, the ethics self-assessment, and then maybe at the beginning of the project, I let this be evaluated by a research ethics committee at my institution and do some early things to take the ethics into account. Ethics is something that you do throughout your project. But then throughout your project, you can still do it in different ways. One is just to do ethics monitoring, right? So you have one person or several persons who monitor the research throughout the project and flag ethical issues and then bring them up for discussion. How can we deal with this? How can we take this into account in the future? So they report on that. So at least you get a nice report on the ethical issues, but you also try to take mitigating actions during your project. So that's one approach. Second approach is, and this is especially so for, of course, for projects where you actually do technology development, where you design stuff, is to do ethics by design. And ethics by design is a new approach that we're currently, that in Horizon Europe, we're going to introduce for AI and data technologies, but that also has broader application to other fields. And it's methods of proactively incorporating ethical values in design processes. So, I mean, we already have privacy by design, right? So you take on the privacy issues as you design. So similarly, now we have ethics by design, where you take also not just the privacy issues, but also other ethical issues having to do with human rights, with freedom, with fairness and well-being, and take them all on board.
So, Philip, you actually started a very, very important point that I believe that I wanted to raise in the fourth question. So, really, how we as researchers can already think about ethical principles. But I was also wondering, what would you tell to researchers who already put so much, especially engineers who put already so much time and effort in developing their concepts, and then they still have to fill, you know, like this massive questionnaire with questions about ethics that is basically, okay, why can't I focus on just on science and then I leave the administration to other people?
Well, the thing with these kinds of projects is we don't have a separate call for the ethics of FET projects, right? And I think the ethics is it's important to do, because if we first do all the FET and do a lot of technology development and then come with the ethics later, then you're a bit late, right? The later you are with your ethics, the less room there is to incorporate ethical considerations in the development of a new technology. And so because there isn't a separate ethics of FET program, I think it's best to include the ethics with FET. But of course, engineers, they're not specialized in ethics. So that's why I recommend get an ethicist on board who can do that. However, if you do so, don't think that you can have a neat division of labor. The ethicist does the ethics and I do the technology, because you do have to collaborate, because the ethicist will learn from the technology, then come up with ideas on how ethical considerations can be included. So it's an interactive process. And that's, I think, also how you have to design it if you create like an ethics task or work package in your project.
Yeah. It actually really, so this morning we had a fantastic interview with a neuroscientist who is a scientist, but she also has a company, and she participates in various PREFET projects. And what she said about ethics, and I found it very inspiring. She said that of course they think about ethics, but mainly because it is important, but how to take care of it, it's because it is in their DNA. So from the very beginning, they thought about developing technologies that actually do bring good for the society. And that is not something that you do on the side, but something that you do from the very nature of your existence, because you put it at the core of your values, either as a research organization or as a company or as an individual. So I found it very, very interesting. But even with good intentions, something may go wrong. So how to really engage ethicists in a meaningful way in your project and find common language, because I have a feeling sometimes that we talk different languages, like ethicists, human rights lawyers, and then engineers. So how to develop this mutual understanding and dialogue between each other?
Yeah, that's a very good question, and it's certainly not easy. I think as we go along with this, we're learning. Every year it gets better, I think. There are more and more ethicists with engineering backgrounds. There are more and more engineers who had an ethics course at their university. So I think that the language gap is getting smaller, and we're also developing more and more methods and tools that are really at the intersection of ethics and technology. So now we have this ethics by design approach that's coming out in Horizon Europe. We have ethical impact assessment method for technology. And I think we have more and more of a common language that we can use, but it requires efforts from both sides to, of course, to bridge that gap.
Yeah. So I think that this topic leads us to the next question, and this is really about the obstacles. So what are the main obstacles in connecting PREFET with ethics, human rights, sustainability, and responsibility?
Well, I think probably the biggest obstacle is what we just talked about. It's the specialization that people have within their own discipline. So, and then I think engineers, they more easily connect with other engineers in other fields than they would with people in the social sciences and humanities, which would include the ethicists. So to still find each other and say, okay, we have engineers involved in this project, but we should also get an ethicist on board. That's an important first step, and not everybody is going to make that step, either because they don't see what the ethical issues are in their work or don't find them important, but also if they do, finding the right person, kind of convincing the consortium that there should be room for this. All those things come into play here, I think. But I think it is currently rewarded in the evaluation structure of the European Commission. That is, I've been involved with a lot of project proposals where it's a technological project, they have an ethics component, and the ethics component is evaluated very positively by the reviewers.
And Philippe, do you see anything very unique or something different from the projects that you do that are perhaps more or maybe more about technologies that are already here or that are in the development versus PREFET? So really future and emerging technologies that sometimes we, as I mentioned before, that it's sometimes very difficult to even imagine how can we use these technologies. And my question comes really from our experience in PREFET when we were developing, as part of this project, also the responsible research innovation approach and connecting our FET trends with sustainable development goals. And during work with Martin, we discovered that it was so difficult for us to connect the potential impact, because you really need to know how these technologies may develop. So,
yep.
Yeah, so is there any special about FET?
Yeah, very good question. And well, first of all, I think that most of the research funded in Horizon 2020 is about emerging technologies, but technologies at different degrees of emergence. Of course, in FET projects, they have hardly emerged yet, right? It's really a brand new concept. So in that case, how do you deal with the ethics comes in a bit differently than when it's emerged, the emergence is further along. And I think then the role of foresight is very important. So there is this discipline called foresight, where basically you try to explore plausible futures, right? So it's not the same as predicting, saying this or that will happen and it will happen 3 years from now. It's really saying, well, what are the plausible futures for this technology? What might it look like in 5 or 10 years, and what are the possibilities? So you're exploring multiple possibilities in parallel to each other. And by doing so, you can then get a better view on what might happen and what we can already do now to influence what will happen, right? So, I mean, so sometimes, of course, we look at the utopian and the dystopian scenarios, right? So what could be the best that could happen, the best future that could come out of this technology, what could be the worst future that could come out of this technology, and what would be the in-between situation, so to speak, right?
Yeah.
And by investigating that, so we have methods for that. We have methods combining ethics and foresight studies. By doing that, you can then explore the future, at least plausible futures, and then look at the ethical risks in different scenarios that you're sketching.
Yeah. Yeah, I think that's exactly the follow-up question. Like, so how do you see the role of ethics by design exactly in this forecasting exercise? So it could be combined. You believe that it's possible to combine with the forecasting exercise as well?
Yeah, I mean, I think what you have to do in any case in a FET project is some kind of ethical impact assessment that includes foresight. So you try to anticipate how the technology may develop and what would be the ethical issues. That's one thing you can do. The second step would actually be to already start mitigating and setting the agenda for your technology development in such a way that you take on board these ethical issues. And that could include ethics by design. It depends on how far you go with your project, whether you actually do concrete technology development, right? You actually design a system or a particular technology. If so, then we do have this step-by-step procedure, which says that at different phases of the design process, you take on board certain ethical criteria and incorporate them in the design process.
I think I lost, I can't hear you, Philip, right now.
Yeah, I couldn't hear you for a second.
I will try, okay. So I'll move to the last question, and I will give the floor to the audience. So the last question, we already discussed a couple of things that we could recommend to or advise the researchers to do, but perhaps, Philip, you could summarize from your perspective. So how can researchers improve their FET-like ideas for projects so that the technologies are socially desirable and ethically acceptable?
Right, so I think it's smart to give ethics a place beyond the kind of self-assessment that everybody does. I think it's smart to include either a task or a work package on ethics. And I think it's smart to include for that an ethicist, but to also make sure that it's a real collaboration, not a neat division of labor. You do your ethics thing and I do my technology thing. You need to have interaction, I think. And then as what will happen in that ethics task or work package, as I said, I think at a minimum, you want to do anticipation. So you want to explore using foresight possible future scenarios for this technology and what ethical issues that may bring. And then you also want to look at whether you can do something with that information in your technological work in the project. And what you can do with that, it depends on what exactly you're planning to do and what the ethical issues are. So that has to be looked at the case-by-case basis. So it could just be quite limited because you're doing quite fundamental research. It would just mainly be maybe steering that a little bit in this or that direction because of the ethical issues. Or it could mean that you use something like the ethics by design approach. I cannot hear you now.
Now it is. Yeah, I think it's just very interesting, especially when you do basic science, and then how do you really ensure that your project includes these elements. So I think that's the main challenge, and exactly like a practical challenge. So we hope that during these training sessions today, but also we're going to meet with you tomorrow. So we're really encouraging everyone to join the second part of this training, and also just after this interview, but also the second day, so tomorrow, to learn very, very practical aspects of how we could involve ethical, fundamental rights, sustainable aspects into the projects. So I think that these were all questions that I had to you, Philip. If you have any final thoughts, you're more than welcome, and I will open the floor to questions.
No, I'm happily entertain some questions. I do have to leave at 3:30 straight, so just to inform you.
No problem, no problem. So I'll ask my colleague Elena if there is anything coming from our audience.
So no, there is no any questions on the question panel. So please, I kindly ask the audience just to make any question or comment.
And otherwise, Philip, you made us think. So maybe those are very, very philosophical big questions for us. Maybe still right. And otherwise, I think that we'll have more opportunities, Philip, to ask you questions tomorrow. So think, guys, about everything what you would like to ask Philip. He's an amazing expert in so many different aspects of ethics of technology that we can definitely learn from you, Philip, a lot.
Thank you.
All right. I think that we can close the interview then, Philip, and I will give the floor to my colleague Martin de Hever, and we'll start the interactive session then. Great. Thank you, Philip. Thanks.
Bye-bye.
Bye.
Hi, Martin. Please send me your mail, the mail with you have entered the session, please, to make you presenter.
Elena, I think that I managed to change Martin's status.
Hi, thank you. Can you hear me?
Hi, Martin. Yeah, we can see your screen as well.
Okay, fantastic. Just give me a second. Okay. Just wait another minute till we get started. Okay. Right, so can you see that okay? I can see my mirror screen. Is my audio good?
Yeah.
It's fine.
1, 2, 3.
Yeah.
Perfect, thank you. Great, okay, well, welcome everybody. This is a session on the application of a number of the things that Philip and Agatha raised in the last session. So one of those is ethics by design, and we'll talk a lot more about that tomorrow. But what we're going to focus on today really is thinking about the responsible research and innovation aspects, which forms arguably part of ethics by design, but I'll try and cover the principles of both in this session. So first of all, I'll be talking about the background to this, setting the scene, what is this really all about, for those of you that are not totally familiar or experienced with responsible research and innovation. Talk about also what we did within the PREFET project in terms of evaluating candidate trends, and how Agatha and I worked on that, and how we did an evaluation, how we developed and updated a methodology to look at a number of aspects of ROI applied to PHET, and then we'll then get into some detail about how we then operationalize that by developing that methodology further, but also by creating a suite of online tools that anybody can use free of charge in order to undertake responsible research and innovation evaluation activities, not only for PHET, but in fact for any kind of technology-based research project in a wide range of disciplines. So that's the range of activities we're talking about in this session. So I hope the audience are happy with that, and you're at the right session and have not actually accidentally turned up for this, rather than going to the cake baking event, which is no doubt happening elsewhere on GoToWebinar. So let me just go to the next slide. So this is the agenda. So I'll start off by setting the scene, and we'll give some background information. We'll use some real world examples. We'll also reference that to some of the trends that were identified within PREFET, and then we'll also try to encourage you to interact with us and give your views on different aspects of this presentation. So we try and make this as interactive as possible. So we'll talk about then applying responsible innovation and ethics by design type principles to PHET. We'll talk about some more detailed things around establishing what we call innovation potential. We'll talk a bit about technology readiness level and its relevance to this, about proportionally applying these processes and these approaches. We'll talk about another thing, a novel concept we've developed called ROI intensity level. We'll then get into something called ROI maturity modeling, which some of you may have come across in the past, and that's really looking at organizational capability in ROI and ethics by design type approaches. We'll then look at some gap analysis type work, and how one might then go on to create an action plan, actually something operationalizes these concepts that you will actually practically implement alongside your technology search. And then subject to a bit of fluctuation in timing, but we should then be able to wrap up around 17:30 or a little before, depending on how interactive these sessions are. So that's the agenda. So in terms of introductions, so Agatha, have you introduced yourself? I'm sure you did at the last session, but I'll give you an opportunity to do that again if we have more audience members.
Sure, thanks. I'm Agata Kurzawska from Trilateral Research and of course from the PREFET project. Okay, and together with Martin, we've been working on exactly on this exciting aspects of FET, responsible research, innovation, and ethics. Yeah.
Great, thank you so much. My name's Martin De Hever, so I'm director of a thing called Orbit, which is the Observatory for Responsible Research and Innovation in ICT. So Orbit is also work on PREFET as well. So Orbit's a UK-based project, now a spin-out company from the University of Oxford and De Montfort universities. And we've been tasked with trying to train the next generation of researchers in responsible research and innovation techniques. So over the next few years, we'll be training about 12 to 1500 PhD students in a wide variety of disciplines. I mean, at the moment, we teach students who are working on statistical machine learning and AI, robotics, space systems, functional coatings, precision agriculture, water treatment, offshore wind farms, all sorts of data technologies, a very wide range of disciplines indeed. But that's our job really, to try and share that information, but also to almost act as a conduit between the more sort of social science type discourse around responsible innovation, and to put that into terms which the more technical research community can then actually apply to their project. So it tends to be translation from these conceptual things into things that are significantly more practical and applicable, and can be actually applied in more technical projects. So that's one of our jobs really, is to try and translate and operationalize a lot of the RI discourse into things that technical researchers can indeed use. So in terms of setting the scene, I'll give a bit of background. It's all kind of real world based, and then I'll reference FET trends wherever that seems appropriate. So setting the scene. So a couple of short videos here that talks about the application of a combination of technologies. Some of these are FET related, and how they can be applied to what can be seen as very different applications. So here's a short video. Okay, so that's the drone technology applied to something that we're calling now precision agriculture. So the concept here is that these drones are loaded up with herbicides and pesticides, and they are actually sent to specific locations where sensors have detected that there is a need for those particular chemicals to be applied. And the intention there is to improve production, to reduce wastage, to reduce overspray, but also from a positive, but also equally a negative, to reduce the number of people involved in the application of these pesticides and herbicides in agriculture. It's also potentially seen as an enabler of food autonomy, because those that are developing and selling this technology assert that this is a way of increasing yields and reducing production costs. Of course, that's yet to be borne out at significant scale, but it may be possible on a small scale. Let's see, and ultimately for the delivery of cheaper food for some people at least. But what go alongside with those apparent positives? Well, are drones actually replacing people? So I think particularly in developing countries where agriculture is kind of the first stage of organisation, that actually to skip the mass employment phase and go straight into mechanisation may be slightly problematic in terms of the long-term development of that country. But also other things like, for example, introducing new technology risks into the food supply chain. I think we recognise in the global north that technology is a big part of our food supply chain. But for developing nations, that may not necessarily be quite the same. So are they introducing new technology-based risks into that, particularly things like cybersecurity, for example, or equally where they become dependent upon exported technology, which may suddenly come under export control. So if your nation is dependent upon this technology and it's imported and then suddenly the supply is cut off or spares are no longer available, does that then expose you to a new set of risk and a new type of threat? Also, the fact that these technologies seem to be fragile and not necessarily as robust as traditional agricultural equipment might be seen. But equally, there's a need for new business models as well to support the funding of that. The availability of finance for rural farmers can be extremely difficult, particularly in developing nations, but I'm sure everywhere. And so the fact is that the financial services sector that goes alongside this does need to be developed as well. So there are some non-technical interdependencies there that should a nation wish to deploy these at scale, or there seems to be a need that deals with a particular local issue, that other areas of innovation are required, not purely based on technology. So overall, I'd like to open this up to the audience, really. Does anybody feel this is overall a positive technology or a negative? Are there any comments? Please feel free to put them in the chat or speak up. I'd be very, very keen to hear your thoughts. No comments? No? Okay. All right. So overall, I mean, it's a good question. I mean, there are pros and cons. I think it very much depends which side of the argument you're on, but there are definitely pros and cons on both sides, which we do need to take into account. So here's another short video. This is an alternative application of remarkably similar technologies, but applied to a very different purpose. Let me just share this.
Your kids probably have one of these, right? Not quite. Dumb weapons drop where you point them. Smart weapons consume data. When you can find your enemy using data, even by a hashtag, you can target an evil ideology right where it starts.
Pretty shocking stuff. So the full video that is available on YouTube and various other places, and was created by a group of academics. That actually Philip Russell, who comes out of Berkeley University in the US, but also a much bigger group of academics who put together a very dystopian view of the application of drone technology. But of course, the enabling technologies for both of those scenarios, the potentially quite positive targeted drone spraying and the generally very negative use of killer drones or offensive military application type drone technologies, there's a great deal of overlap there. So if we were to look at the component technologies, these are the things that actually enable both those scenarios. So we have lightweight propulsion systems. There's a great deal of research going on in that area for applications in airliners, for example, for electric airliners, or airliners that use electric motors in the crews, and combustion engines for takeoff, for example. Advanced materials for airframes and other things. Again, a lot of research going on in that area. Big area of research now is, of course, in high energy density batteries as an enabler of network attached storage for balancing out loads in power distribution networks. For example, where you have wind farms, and also with photovoltaic cells, there is a need for large scale energy storage technologies, and the energy density of those is going up significantly over time. So that's a lot of research in that area, but it's an enabler of longer flying drones as well. Computer vision is part of it all. Both of those applications seem to use computer vision technologies for target identification, be it for an offensive application or for an agricultural application to target spraying. Many other things as well: autonomous control systems, machine learning, lightweight manufacturing, and the like, and equally new business models, because both of those, in both of those videos, they claim, or the technologists around those claim, that actually new business models make the technology more affordable for both applications as well. So it's not just the tech itself. In terms of referencing PREFET trends, or the selected trends that PREFET came up with, there are 3 that are relevant to this application. So one is neuromorphic computing. So one of the early applications for neuromorphic computing is around computer vision. So this provides a high performance, very, very low power way of doing computer vision at the edge, as I say, at the edge. So this is very much an edge application. There is no time when you're flying a drone, because of network latency, to do any kind of image processing at the back end. It's got to be done at the edge. So neuromorphic, definitely part of that. Ethical and trustworthy AI and autonomous analytics. Well, you might argue that all these systems have elements of autonomy within them, and so that does need to be developed and operated in a trustworthy and ethical manner. So in both applications, because there will, even in the battlefield situation, there are terms of engagement. So even in that situation, there are rules about what you can and can't do. So equally the same for agriculture. So, and then beyond that, things like beyond 5G hardware, and that's one of the other trends that we identified. So this is a way of reducing. So this is obviously one of the use cases for 5G technology is a low latency, a low delay technology, and B5G is meant to go beyond that, and also potentially as an enabler of things like stigmergy. So stigmergy is a drone swarming approach, bio-inspired. So actually inspired by insects who use pheromones to share information to identify things that they are looking for. And stigmergy has been implemented technically for drone swarm technologies, for target identification, for the sharing of information across large numbers of imperfect sensors. Very much a kind of a swarming or flocking approach. So there are 3 trends that PREFET picked up that are all enablers of both of these drone application scenarios. But as the slide says, both scenarios have very similar innovations involved, but very different applications. So they're really quite close. They're much closer than any of us would really like to think, agriculture and offensive military. So as I mentioned, battery life's a big issue for many of us. If you've ever driven an electric car, even now, even with the best cars, that range anxiety is a real problem. But if you're flying a drone, if any of you have a drone at home, you'll find the big issue is, apart from operator fatigue or the lack of operatorability in flying these things, is the fact that the batteries don't really last very long. And when you're carrying a heavy load, that obviously significantly increases battery power. So really a big issue there. But bringing this home, of course, here are a couple of examples of research going on now. On the right, we have an example of a graphene applied to high energy density batteries. There's a paper there basically saying that it is possible to significantly increase energy density, and we're certainly seeing other research in that area that does the same thing. And on the left, another research project looking at reduce power consumption for, again, edge computing. So both of those could, in theory, significantly reduce the power. One would reduce the power consumption requirements from a drone. The other one could increase the energy density. So in fact, the Achilles heel of drone technology for both agricultural, which is good, and military, which is in some circumstances not so good, not always, of course. In some eyes, an increased battery life may improve or increase the effectiveness in agriculture, but also the lethality in the weapons scenario, albeit for a state actor or a somebody who is from an asymmetric background. So, what is ROI and ethics by design for PREFET? Well, I think the point we're trying to make with all this, and I hope it's come out in these illustrative points, is the fact that ideas and innovations are not necessarily always motivated by very particular end products. We may be working on something, it may be on batteries, it may be on AI, it may be on machine learning, it may be on materials or any of these things. And we don't, as researchers, necessarily know where it's going to end up. You can try and do foresight, but foresight doesn't have a great track record. Rather like the what they call it, the Cassandra syndrome. You're given the ability to see the future, but you're also given the curse that nobody believes you. I think foresight is often suffers from that. People will try and see the future, and maybe they may even be right, but nobody believes them, and so nobody does anything about it. So you don't necessarily, it's not just about being right, it's about being believed, and that's difficult because nobody really knows the future. So the challenge is we work on things we really don't know where they're going to end up. So how on earth can we be ethical by design if we don't necessarily know what the end products are? It may be that what we're thinking about now seems to be, we may be thinking about precision agriculture as an application, and that sounds great, and we can see how food autonomy can be restored and Africa can afford to feed itself. But it may also be applied to other things that we are much less happy about. So even if there are unforeseen consequences that we can't even predict, we don't even know, it's really the unknown unknowns, we still can't stifle technology. We don't really want to be accused of applying these techniques to be sort of nannying technologists at the same time as stifling technology. If at the same time it seemed to be a way of constraining innovation, stopping breakthroughs that are seen as being potentially valuable, albeit with some commensurate risks, there is a real challenge there. So if you can't be specific about what the product is and what the application is, you could say, well, you can't develop something if you don't know what it's for. Well, that clearly is unacceptable. So we can't be seen to be stifling technology. There are many things that are extremely useful in our world that have been applied to other applications and have found their new purpose at some point in the future, and it was never even considered. So how can we find a way that we allow innovation to happen, but keeps researchers in the loop and the rest of society aware of what's coming, so that they can try and prepare themselves, so they know what's coming? So if there's going to be a change to how they're employed, for example, then they can see that innovation coming and so hopefully prepare themselves in advance. But as researchers, if we're working on PREFET, we don't necessarily know what the applications are going to be. Even if we do, we're not necessarily in control of them. So the question is, are there things we can do technically to try and build in controls so that if and when something is used elsewhere, are there measures we can take in order to try and offset that risk, even though we're not actually in control of the practical application, even if we do have the ability to see the future? So that's really what this is all around, how we can actually create a method and approach and operationalize that without constraining innovation, by letting people dream, by letting people seek out new knowledge and explore the limits, at the same time trying to avoid decimation of our environment and our society and our world. So it's a real challenge, So opportunity for some discussion now. I presented quite a lot of information there, and just be very keen to hear from somebody around how you think ROI might be relevant to the work you do, considering those things, and how might it be relevant to your own lives? Would anybody care to share an anecdote or a story about how they feel that a technology they've worked on has maybe been misused or been used very well, for example? We would be very happy to hear your examples. So I'll leave the floor open. Feel free to comment in the chat or to speak up if you're. I'm not sure that microphones are allowed. Actually, are they allowed to speak? It's their permission to. Do you know?
Our audience is allowed to write questions in the question chat.
Okay. But is it possible to enable somebody's mic or not? So.
If someone would like to speak up, we can give, of course, rights to speak up if someone would like to. For now, we don't see any questions. Both Elena and me are monitoring this.
Okay, very good, Fredo. So I will give an example. Thought that might happen. So offshore wind farms. Here's an example. So it's something that I think that many countries that have that are not landlocked, of course, because you can't do offshore if you don't have any water. Offshore wind farms are seen to be a big thing. So the UK government and many other governments have made commitments to make offshore wind generation a cornerstone of their net zero policy. We've just made a further commitment to deploy many more of these. And one of the challenges is, of course, you start off with the best locations, and then over time, the locations that you need to deploy these wind farms in are less and less good, less and less optimal, less and less acceptable to the local population, and introduce other issues as well. So the quality of the installations inherently will go down just purely because there are many more of them, and you can't put them all in the optimal locations. Some will be in less than ideal locations. So that's a reality. We're seeing this kind of thing happening more and more. There is an ongoing commitment to move to net zero, both using photovoltaic technologies, but also wind generators as well. But unfortunately, there is a problem that goes along with that. And this particular problem is to do with how offshore wind farms have an impact on civilian and military radar. So it's a known fact, in fact in the UK, I'm sure true in many other countries as well, that around half of the offshore wind farm projects that are currently underway have got objections to them, mainly planning objections from local airports and also from military operators who are concerned that those wind farms have an impact on the radar surveillance services that they provide. So for civilian air traffic control, that has an impact on air safety, because if surveillance is ground-based surveillance is not in place, then there may be gaps in radar coverage which could endanger aircraft's passage. So equally, from a military perspective, if a large array of offshore wind farms interrupts military radar, then there is a vulnerability, a new vulnerability which is introduced to low-flying aircraft and also missiles from other nations looking to attack. So these are real. This is really happening, and a significant number of these sites actually have objections against them. And you can imagine the conversations, well, which is more important, climate change or our ability to defend or at least operate large numbers of passenger aircraft safely. So you can see that being a really very interesting debate. And of course, as more and more and more of these wind farms are planned and deployed, the locations will become less and less optimal. And so it's likely that the number of these sites that have an impact on surveillance, on radar surveillance, is going to get worse. So some funding has been made here, and I'm sure in other countries, to try and mitigate those issues, to develop technologies to mitigate those kinds of things. Very much an RI problem. You know, we want wind. Everybody feels that wind is a very positive thing. I know there are some that don't, and a number of conspiracy theories about wind. But the truth of the matter is, it is probably one of the few hopes we have to get anywhere near net zero. but there is a problem that goes along with it. So another area for research. So this will be seen as a technical mitigation, but of course, you know, it can't be mandated. It's just something that's that needs to be developed. But of course, you can't guarantee that that will be in place everywhere. So this is a real world situation, and this is an approach to addressing it. Of course, the other approach would be to stop the deployment of wind farms, but of course there'll be many knock-on effects from that as well in terms of energy policy, but also ultimately through climate change. That would have a huge impact. That was not allowed anymore. So the debate continues, but yeah, there's a technical mitigation for what is quite a complex problem. So the question is, in these kinds of situations, who has agency? You know, we as researchers, we have some control, but there are many other parties to this, because we may have a particular perspective on the application of our research. As a researcher, you know, we've all done this ourselves. We don't like to admit it. We tend to have a rather rosy view of the work we're doing, and although we do our best to anticipate the negative aspects, we are not necessarily objective about how dangerous or desirable our technology is. If you spent 20 years working on nano materials, and then all of a sudden there's a problem, clearly you're going to try and resolve the problem, but you will still have a rather less than objective view, I'd like to say. Potentially, of course, there may be others that can be entirely objective, but there is a real risk if it's yours that you are not necessarily able to appreciate and apply proportionality to issues that are outside of your sphere. So we look at others who have agency here. Well, markets being in terms of products being bought and sold, consumers themselves, so those actually buy technologies and apply them to particular applications. They can, of course, have an issue of choice, and so they may be able to avoid things that they find unacceptable or problematic. So companies themselves, either as manufacturers, but also as effectively OEMs, original equipment manufacturers, systems integrators, for example. Employees, so employees of a company, employees have some role to play in all of this as well. You know, are you happy to be working on that technology? Do you feel that it's something that you really don't want to be working on? There's some great examples in recent years of things like the Microsoft HoloLens headset. There was an open letter written by Microsoft employees basically saying that they were unhappy that Microsoft was selling the HoloLens technology to the US Department of Defense, and they were writing on behalf of themselves, but also on behalf of all the researchers that had gone before, who'd worked on HoloLens, thinking that this was a gaming technology, that it was a technology that was going to be used for fun applications, and they at no point apparently thought that this could be used for offensive military applications, as the DoD is intending to do, as these will be battlefield headsets for infantry people. So there are examples of how employees have tried to influence how companies actually do their work. Researchers will talk about in a moment. Governments have some role to play, although anticipatory governance is not a well-trodden path because it's quite problematic. Although there are some aspects of GDPR which would certainly be seen as anticipatory in their nature. The things around the explainability clause within GDPR have some influence on autonomous systems, although there are some loopholes which I'm sure some of you are aware of in terms of the need to have a human at least somewhere involved as a get-out clause. So who has agency in these situations? Well, a number of people do, but of course not all of these people are created equal. Some are more equal than others. So, okay, that's a bit of background, a bit of an idea of what we're trying to address here. Now I'll get on to some more practical aspects. So applying ethics by design and responsible research and innovation approaches to future and emerging technologies. So what are we actually trying to achieve with all this? Well, it's all very well to say, yes, we can see a case for, sorry, just bear with me a second. That's better. So what are we trying to achieve with all this? So what we're trying to do is, when we apply RRI, we're trying to do it in a proportional way, and the same applies to ethics by design. So the first thing is, can we actually meaningfully apply this approach? Are we actually really aware of the potential applications of a technology? It's very difficult to come up with any kind of solid evidence to show that these things will be used in a particular way. So can it actually be meaningfully done? And that's quite difficult. We need to have some kind of evidence. Is it actually useful at that particular stage in the evolution of a technology to actually be doing this work, or do we feel that we are unnecessarily constraining innovation? So this introduces a temporal aspect to all of this. Are we actually doing it too early? Are we trying to force a technology to have an instrumental value far too early in its life cycle? Philip earlier on talked about technology readiness levels, and we will be discussing those shortly too, because they play a part in this methodology, very important part. So are we actually forcing research that really is at a basic stage, maybe at TRL, 0 to 1 or 2, whatever? Are we forcing them down a particular route? Are we constraining innovation too much when we really don't know whether this even works? It's just an idea. So the usefulness part is an incredibly important test. There's also an issue of the sensibleness of it as well, and the sensibilities of undertaking these activities. I think some of the RI methodologies can be seen as rather a large overhead. Now, for some projects, it's absolutely essential and it's totally necessary, and for others, it may just be a bit of overkill. The question is, how can we establish what is appropriate, what is sensible? So, what resources are we putting into this? Philip earlier on talked about the idea of is ethics separate from FET? Well, of course it's not. It's got to be embedded. It's got to be part of the same process. It's not really being done separately unless you're doing some sort of meta study. This kind of thinking has to be done alongside the technological development as well. So the question is, what is sensible? We can't, if something's seen to be particularly risky, do we end up spending all of our budget on the ROI aspects and not actually on the tech if it has benefits as well? That's a real challenge. So sensibleness is very important. So it's all about proportionality, and that's a combination of the stage of development of the tech, the impact or the perceived impacts across many different areas, and is it an incremental or transformational change that technology would bring about. So the sensibleness of it is an important test, and ultimately, after all this, is it actually going to be effective? If we actually do RI, if we implement these kinds of approaches, if we implement ethics by design within our project, can we actually come up with enough evidence to show in our project that actually things like anticipatory governance, for example, are justified? If you say, well, here's the technology, it's incredibly beneficial, but it has some risks to go alongside it, do we actually know that can be done? I'll give an example here. There is a rare earth mineral called tellurium, and the tellurium is seen as being a key component and at least one of the new photovoltaic cell technologies. So there's a lot of work going on at the moment to develop much more efficient solar cells, not based on silicon technologies. So people are doing work on hybrid substrates, polymer substrates, organic substrates, and the active layer. There's also work going on there, and tellurium is one of the components of those high efficiency solar cells, which are seen to be incredibly important. However, the level of deposits of tellurium on land are really very, very small. It's actually a really small concentration in the sources that have been found, but they have in the last couple of years found a very, very large reserve of extremely high concentration tellurium just off the west coast of Africa in the sea, on the seabed. So this it's an undersea mountain. It's very large. It has something like 50,000 times higher concentration of tellurium than it does on land, and so by mining this, it would potentially open up the market for these high efficiency solar cells. Problem is that the sea bed where it is pristine, a pristine ecosystem, untouched by humans, or largely untouched by humans, apart from obviously things like sea level rise and warming of the seas and all that, which would be probably pollution as well. But it's seen as being pristine ecosystem, and so there's a huge outcry about digging this up. But at the same time, it's seen as an enabler of a non-carbon future for energy production. So how do we resolve that? So can you come up with enough evidence in your research to say that it's worth it, that it's worth the impact? Or is there enough evidence to say, well, actually, you really shouldn't be doing this. It's just totally not worth it because there are other minerals out there that will do the job better, for example. So that's an idea, an example of can we actually do this in an effective way? Can we make a case either way for doing it or not doing it? And so that's incredibly important that we establish enough evidence to allow these things to happen. Okay, a second, there we go. So in terms of actually operationalizing this further, this is the process that Agatha and I put together, and others have worked on this since and taken it forward and innovated it and validated it in other ways. But this is something that we developed. So for a technology trend, so this is something which is seen as a future and emerging technology area of interest for the future. What we did is, first of all, look at all of the published literature, or work with the subject, or in some cases work with subject matter experts to establish a sufficiently wide range of use case scenarios. So what it does or what it can be used for. So this is looking at this is anticipation, or it's really looking at what the application of a technology trend actually is. That's the first thing. The second thing is to look at impact measures. So how could a technology trend have impact on something that a lot of humanity feels is important? In this case, we have used the example of the Sustainable Development Goals. It's something that's been signed up to by 70 or so nations, or more than that now, and is seen as a broad set of measures of what humanity feels is important. It's by no means exhaustive, but it's a pretty good cornerstone for what a lot of humans think are important. So there are 17 Sustainable Development Goals, and underneath those, I think 169 specific indicators and targets that again operationalize those goals. So that's the measure that we use. The third one is to look at evidence of any impact on the SDGs. So if we've said, here's a technology, this is what it's used for, this is how we see that particular use case applied to the SDGs, we then try and work out whether that impact is in any way quantifiable from a valid source. So can we find somebody important with sufficiently robust evidence, again, better than the Muse test, you can actually say that this impact is one that is valid and quantifiable. When you actually start looking at effect trends, that's really quite difficult. It's not an easy thing to do. I think across all of them, there were certainly two. There may have been more than two, but the two that come to mind, one was on autonomous vehicles, where there is a US Department of Transport study which says that should autonomous vehicles be implemented ubiquitously and globally, then the currently 1,200 people, 1.2 million people are killed on the roads every year worldwide, and that figure would be reduced by about 94% if people didn't drive cars anymore. So not that there aren't any cars, that the cars are driven autonomously. So I think that's quite a wild figure and would need huge qualification of what that actually means, but there is a reference point there. So there is an example. The other example we found was on the use of non-opioid pain treatments and the impact on death from opioid overdoses, and I think there was some figures there from the WHO around that. So that was associated with the trend for candidate trend for non-opioid pain management. What we then try to do is to document SDG impact, target indicator impact, and then look at effectively tabulate all of this information. We try to indicate innovation potential for a particular technology. We estimate current technology readiness levels, so what stage the technology has got to. This is the idea of what confidence do we have that this technology will deliver its benefits or not, and to what extent can we indeed try to design mitigations or ways of addressing the disbenefits of this technology, along with maximizing the benefits. So TRL has an impact on that, a big impact. And then we combine all that information to convert that into something we call ROI intensity level. So that's it. It's what we've tried to do, because actually having gone through this in a very, very manual way, Agatha and I actually went through a large number of trends, more than 45, and actually did all this pretty much by hand. And I think we found that actually the creation of a tool to operationalize this would make this process a lot easier, and also produce a much more visually pleasing output than very, very large Excel spreadsheets. So we learned this the hard way, but that's the way to do it. So we now move on to establishing innovation potential. So this is the potential of an innovation to change the world. So I'll just show a short video on the Sustainable Development Goals. Okay, so I'm sure many of you are familiar with the SDGs. Let's have a quick look at those. So poverty, no poverty, zero hunger, health and well-being. You can see the selection there. As I said before, under these 17 goals that were originally enhanced from the Millennium Development Goals, these seem to be a set of goals that are much more balanced across global North and global South. I think the Millennium Development Goals were seen as being the global North telling the global South what it should do, whereas this is apparently, supposedly, I can't really comment, but much more balanced in both directions. So there are 169 indicators and targets that sit below these, which are sometimes very relevant to a technology. Should we be able to look at the broadest possible applications of that, really thinking outside the box? So these are our goals. So in terms of simplifying our method, our approach is to say, can we see any impact on those SDG indicators at all? If not, then we would call this innovation potential 1. So it doesn't mean to say the technology is not useful, but it's that we can't see an impact across these broad range of goals. Now, I think it is very important to say, but before we get into this in too much detail, that this is very much a transdisciplinary approach. So doing this within a particular discipline has value, but it does need to be done across a wider range of disciplines as possible. And that is not without its challenges. But if, for example, you were working on some algorithmic development, you would think about this in terms of maybe the maths department or the stats department in which you're sitting. But there may be other applications for this in other areas. And so as far as reasonably practicable, it's important to try and get that information about what this does in front of as many people as possible. Now, practically, this is quite difficult. If you're doing this in academia, it's a little easier because obviously we do that through publications, for example, although clearly there are issues of language as well. If it's couched in certain terms, it may be that it's not that easy for others in different disciplines to understand the principles of. So science communication is an incredibly important part of this, to communicate in as straightforward a language as possible the merits of this technology. So that's incredibly important to get out of our disciplines and to get into other areas where others may consider this useful for them. So this issue of the ability to communicate and language and how we share this information. Of course, this is quite hard when we consider the commercial aspects. If you're working in a company, maybe some of the value or a lot of the value of your company is in its intellectual property, and nobody wants you to be giving that information away. But it doesn't mean to say that this work cannot be done without considering the impact on intellectual property, for example. So innovation potential 1, it means that there's no direct impact on the SDGs, but the trans or interdisciplinarity of that is incredibly important. You can't just talk to your lab colleagues or speak to your supply chain, but you need to get out of the box as well. But again, back to this issue of proportionality. Is it too early in the technology life cycle for that to be done effectively, or is it too late indeed? So, but again, that applies to all of these areas. Second one, unquantified impact on one SDG. So we can say there's probably an impact on one of the areas, but we just don't know how much. We can't evidence it. So that's innovation potential 2. So that's seen as being a high level. Innovation potential 3, unquantified impact on 2 or more SDGs. So it means that you think there's areas of impact that are meaningful, but you can't really quantify them. Then we get into IP4, where SDG is impacted, but it's quantifiable. Tend to correlate with a higher TRL technology. So it's quite difficult to do that in early stages, although it may be possible. But these are things that tend to be associated with higher TRL technologies. And quantifiable impact on 2 or more SDGs is the kind of the highest level that we have, and that would be innovation potential 5. Sorry, this slide has got slightly corrupted. So just talking about all of the trends we looked at, this is the distribution of impact across the Sustainable Development Goals of those trends. So one being poverty, you can see the largest one by far is health. SDG 3, that's seen as being the one that so many of the technologies had an impact on. I think it's important to note here as well that these impacts, although we get you within the tool that we built to record these impacts, here we're not differentiating between positive and negative. They're just impacts. There's no sign in these. It's just cumulative numbers of impacts. So it may be that some of the health ones from one technology are counteracted by some of the benefits for another technology. So this is purely an unsigned calculation, but you can see by far the vast majority have an impact one way or another on health. So it gives you an idea of the distribution. So I think we felt from this that actually the impact on the SDGs was a pretty good measure. Because if we found that none of the technologies had an impact on the SDG or only a few, that would really be a problem. And I think we found that pretty much all of them, in fact all of them, had some kind of SDG impact, although not that many were quantifiable. So here's an opportunity for a short discussion. Really appreciate your comments and questions via the chat. What do you think the SDGs have to do with me? Do you have you heard of them before? Do you feel that any of these areas are relevant to you? And do you think that they're relevant to the work you do? Do you feel they're relevant to your own life? Because obviously these are meant to be, you know, for humanity's representation, or some representation of what a lot of people find important. But do you think they're relevant for you? Do you think they're relevant for your research? So I'd appreciate any comments in the chat on that. I'm just going to take a quick drink to rest my voice. If you could let me know if there are any comments, that would be great.
Of course, for now I don't see anything. But
Okay.
guys, if you need a little bit more time, we can wait a couple of seconds. Perhaps you're writing. Okay, there's one comment, one question.
Okay.
It's from Rosella. I work in drug design and development. I think it is related to SDG 3.
Okay, just bear with me a second. So I'm sorry, I can't see the chat at the moment, Agatha. So could you read that out to me again? I'm so sorry.
Sure. So Rosella wrote that I work in drug design and development. I think it is related to SDG 3.
Yeah, yeah. I mean, absolutely, it can be. I mean, SDG 3 is associated with health, but of course it can have impacts in other areas as well, and things like mobility and other things. So, but equally there are environmental implications for drug design as well, in terms of the use of raw materials or the manufacturing process, and of course economic impacts as well, and things like divisions in society, because of course some pharmaceuticals can be very, very effective, but only available to very limited portions of the population that can afford, for example, highly personalized medicine, so genetic medicine. Do you have any comments on that? Would you like to have your microphone switched on? It'd be great to hear your voice, and we can talk about it a little.
So I tried to unmute Rosella, okay, Rosella says that she has no microphone. Sorry.
Oh, okay, okay.
You can try. Yeah, Rosella, if you make it, just speak up. And we have one more comment from Lucia, and she says, "Is really the impact in the SDG an aspect considered when evaluating a proposal? Sometimes it is difficult to find the impact, and we are not sure whether it's worth the effort."
Yeah, I mean it's a very very valid point. I mean, as I said in the evaluation that Agatha and I mean, you remember that process we went through, Agatha, in terms of looking at quantifiable impacts. I mean, we found those two, didn't we? One on autonomous vehicles and the other one on non-opioid pain management. But there weren't many others, were there, that were quantifiable?
Yeah, I think that this is exactly the question that together with Martin we were really struggling with, especially in FET, and that's why we also try to trigger Philip a little bit, how to really see this kind of impacts in FET. It is definitely easier when we talk about technologies that are here, or we're just currently developing them and just improving, but FET has such a specific nature that even for us it was quite difficult to quantify the impact. And actually, because of that, what Lucia say is, okay, whether how intense is this impact, and to what extent we should really take care of it, right? So this is for this methodology that we applied with Martin. We try to figure out, okay, to what extent, whether we should care, and to what extent we should care. We don't have good answers yet, but we definitely know that what we try to develop for the method for this methodology is to highlight potential for that something is there. something's there. We don't know exactly what yet, but there are some potential impacts that might be very severe. So that's why such project would require further oversight from the ethics and human rights point of view.
Absolutely. I mean, I think as we go through the method, I think this gets borne out somewhat further, doesn't it, as we actually get into how we actually operationalize this fully, because what that does do, it leads us into the organizations, the research organizations' competence or maturity in doing these across the EU pillars of RRI. So that's where these kind of conversations start. We haven't quite got to that stage in the method yet. So what we're trying to do is to say, well, if this is more impactful and we can quantify that impact, then surely more insight is required. And also, if it's nearer to deployment, then we need to know quite quickly that these impacts are coming, so we can come up with mitigations if they're needed, and also workarounds if there are the benefits far outweigh the risks, but the risks are still not sufficiently mitigatable, and they need to be addressed in some other way, which takes time. So this is what we try to do. I'm sorry, what was the other question as well? There was another question about drug discovery.
No, there was the same question from a comment from Rosella about the mic, so that's why you can see it. But I think that perhaps we could also refer to what Philip said. What is important in projects is exactly, I think, that what we had in mind, that it's really about having a monitoring system in place in your project, so that, okay, we may not know at the proposal level that there's something is there, but it is worth to have a monitoring system or tool that for all your project you monitor what's happening there, which direction are you developing your tech, so that perhaps at the beginning you have no idea what potential impacts might be, but with the tech development in a very agile way, you try to identify exactly these potential impacts, because with knowledge, every knowledge you gain about your technology, you know about this technology and potential impacts more and more and more. So with having already at the proposal level, having a monitoring system in place, this is already something that gives you a very, very good step forward to identify and mitigate potential risks. And of course, it's not only about mitigating risks, but also actually developing technologies that are, will be picked up later on, so that they are really helpful, useful, and needed by the society.
Yeah, that's a very good point. Thank you, Agatha. That's very helpful. So hopefully that covers it. But I think as we go through the method further, these things will become a little more apparent. But thank you for your input. I really appreciate the feedback from the audience. Thank you so much and we'll have a few more of these as we go, and we're very, very happy to take your questions and share our experiences. So thank you for those. Okay, so I'm sure many of you are aware of technology readiness level, but for those of you that are not, I'll just talk a little bit about that. So first of all, the question is, why are we including technology readiness level? Well, there is a temporal aspect to this. What point is the technology developed to? How long is it going to be until it realizes its benefits and risks? Because forewarned is forearmed. We talk a bit about in the RI discourse about the fourth industrial revolution, and one of the characteristics of this one, which differs from the others, is the speed of flash to bang, as they say. So flash being the idea, bang being the impact. So these days, with the democratization of technology and development tools and channels of manufacture and distribution, which is actually not just software these days, of course, with things like 3D printers and whatever, and the availability of other technologies, it is actually possible to develop these things outside of the lab. In fact, outside of any organized society. So the question is, we do need to be forewarned. The question is, when do we need to be forewarned if the speed of innovation or pace of innovation is so high? So why is TRL important? One of the things that TRL gives us is the indication of how much confidence we have in the understanding, both qualitative but also quantitative, of impact. So you may say there's impact on the SDGs, but how confident are you? If a technology is just naught, just like an idea or one or whatever, very early stages, we may like to think that our technology is incredibly impactful, and it may be the most important thing ever, and it may indeed, that might be the case. But how much confidence goes along with that? Because could we actually get anybody to take action for a technology which is 30 years away and may never come to fruition, either because it's not viable, or it is viable but it's not funded, for example, or it's not seen as a priority? So this issue of confidence in our foresight is incredibly important, and TRL does help with that. The more mature it is, the more we know about what it does and what it might do in the real world. By no means guaranteed, but the TRL does give us an indication of how much time we have. So that's why TRL is important, and it fits into this idea of it being meaningful and useful as well, and ultimately effective. So it's a short video on the technology readiness levels for those that are not familiar with these.
Technology readiness level, TRL. Technology readiness levels are a method of estimating a technology's maturity. So what are the TRLs? TRL 1. The basic principles are observed and reported. To help you understand in simple terms, I'll use the example of a tire. So one day you're playing around in a lab and it hits you. You come up with a new synthetic rubber compound. You report it and start investigating. Well, what's next? TRL 2. This is where invention begins. The basic principles have been observed, so practical applications can be formulated. In the case of the rubber, this rubber could be used for vehicles' tires. TRL 3 is the proof of concept. Analytical and laboratory studies are required to see if the technology is viable. The rubber is tested for strength and forming capabilities to prove it's suitable to be made into a tire. TRL 4, laboratory testing of a prototype component. Here, you test the rubber to see if it has appropriate wear characteristics. TRL 5, laboratory testing of the integrated system. The rubber is used to construct a prototype tire and tested on a wheel. TRL 6, a prototype system demonstrated in an operational environment. The tire is mounted on a wheel and tested on a rolling road. TRL 7, the design is virtually complete and tested in a real environment. At this point, the tire is tested on a vehicle on the road. TRL 8, proven to work under its expected conditions and certified to be used. The certification will allow the tire to be used on the road. TRL 9, the system has successfully proven to function and is ready for commercial deployment. The tire has been tested through a life cycle to ensure it is safe for use. Above TRL 9 is introduction to the market. The product is launched commercially. These are the technology readiness levels brought to you by Warren Barth. For more information, check out the description below. Thank you for watching.
Martin, we have a comment from our audience, from Cecily. Okay, she was away for some time, but perhaps we mentioned it already. So, as she says, arise as words seem to have disappeared in Horizon Europe drafts. is the ethics and UN SDGs and open science and the free also, I believe she wants to say, that is replacing it?
Yeah, that's a really good question. I don't think we know is the answer. There's an ongoing discussion about that. I mean, I'll give a personal view, but I'm not speaking for anybody apart from myself. But it feels like RI has gone from something which is a topic of research. If you look under the SWOFS program, so Science with and for Society in Horizon 2020, there are quite a number of funding calls there that addressed RI related issues. And the impression I get is that, again, I might be wrong and it's a purely personal view, so please feel free to disagree, it's fine. My feeling is that it's moved from being a research topic to being an implementation thing. And so it's not something that's going to be researched anymore, although clearly there's a lot more work to be done. It sounds like they're transitioning this from now it's time to get on with it. I could be wrong, maybe it will reappear, but that certainly seems, that's my personal view. Does that answer the question? Yeah, sorry, I can't see the chat, so.
She says okay.
Is that okay? Yeah, I mean, I'm sorry, I can't provide any more insight from that. I mean, there are those that say that things like ethics by design, secure by design, safety by design, for example, are things that are almost like an operationalization of kind of RI principles into a kind of a practical methods. And again, I'm not sure they're necessarily quite, well, certainly the ethics by design, not necessarily quite there that in terms of a full method. But it feels like that's the way it's going. That this is something that we try and embed within design process. Just out of interest, one of the things we're seeing, certainly in the United Kingdom, there is a new, what they call a publicly available standard, which is not a ratified standard, but there is a standard called PAS 440, PAS 440. And this is something that's been developed by a team of academics in it and industry partners, so companies and also some academic leads. And this is a methodology for what they call responsible innovation for industry. And so what they've done is they've created a method that looks at both benefits and risks across a particular innovation. It takes into account the multiple iterations of that innovation. So you're required to maintain a register of benefits and risks across a wide range of categories as the innovation proceeds throughout its life cycle. So it has it alludes to technology readiness levels within PAS 440. But what it also does, it also looks at organizational competence or organizational, in fact it's ethics, in fact. And what they're doing is they reference ISO 26000, which is the corporate social responsibility standard, as a method of assessing an organization's corporate social responsibility credentials, as it were. What they say is that you should assess your organization, or across the board, to see whether it aligns with these principles, but then you need to look at each innovation that you produce and throughout its life cycle update its broader societal benefits and risks as well. So that's kind of an interesting step forward. So it's moving forward from responsible innovation to more of a downstream activity, so things from maybe TRL 6 to TRL 9, and that standard it's not public, it's not a ratified standard, it's what they call a publicly available standard. But I'm told that was published in April of this year, and it has had more downloads than any other publicly available standard ever. So there is a real demand for it, which is very interesting. So, and we're actually going to be teaching some courses on that to some of the research bodies in the UK before the end of this year. So it's a brand new publicly available standard actually looking to operationalize responsible innovation, but for industry, which is interesting. So again, that may be another moving from a research topic into a practical topic that can be applied in the development of technology. So whether there's a trend there, I'd like to think so. but that remains to be seen. Does that help?
So Cecile, a follow up on her question. She says, I thought of the concept of the concept co-creation, co-design, and co-creation as the three O's. Codes. Okay. So just a clarification.
Is that a question, or sorry, is that a question?
It's a comment. It's a follow-up comment.
Okay, very good. Thank you for that. Okay, let me press on. So if I may, please feel free to stop me. So this is you probably can't read the detail here, but these are all the trends that we looked at as candidate trends. Gives you an indication, as you would expect, that a lot of these trends were at TRL2, so very early stages. You would expect that for effect technology. A good number were at TRL4, so small scale prototypes. So again, maybe obviously it depends how long it takes from going from a small scale prototype to a fully productionized technology. But we did see a few. So for example, the AI in genetics and bioinformatics were seen as being actually at a high level, but that may be an issue with the way that particular trend was defined. That I'm sure there are aspects of that are at a much early stage. So, but as you can see, it's a fairly what kind of the distribution you would expect. I mean, you might argue that something that's at TRL7 or certainly at TRL9 is not really a future and emerging technology. If it's at TRL7, it's been demonstrated at in a real environment, so it probably isn't really not really a FET technology. So these were our results based on the TRL assessment of those. So what we try to do is we combine the innovation potential, which is the impact on the SDGs, with the TRL, the technology readiness level of the technology, together into a thing called RI intensity level. Here's our table. We have innovation potential along the top. If you remember, IP1 just means that there's no clear impact on the SDGs at all, and IP5 means that there's clear impact and measurable impact on 2 or more SDGs, IP5. And TRL 1 to 9 is fairly self-explanatory. So the more mature it is and the more impactful it is, we believe that it requires and is possible to deliver a much higher level of ROI oversight or ROI intensity than a technology which is at a very early stage, which is not seen as hugely impactful. Because if something's not seen as hugely impactful, clearly very much subject to the how exhaustive your study has been on its potential impacts. It's probably not worth spending a huge amount of money on assessing its impacts if you have confidence that it isn't very impactful. But something that is seen to have a lot of impact, and you can demonstrate that impact is measurable and is also quite mature, would justify the expenditure and the time and the thought into putting undertaking a very extensive ROI activity for that project. I think it's fairly obvious. There is somewhat more to this, as we learned from experience. Experience is a great teacher, really. This was the Trendington activity that happened in Madrid last year. We had a fantastic group of experts there from a really wide range of disciplines, from architecture to quantum computing to medicine and many other areas too, and they were very, very engaged indeed and gave us some great feedback, very constructive and useful, and we actually had to amend our method based on what we learned at that event. So great way to try this out, and we were very much exposed then, because we put all our trends up there and what we thought of them, and we got some very solid feedback. So it was great to test this in the real world, an incredible opportunity, and I must thank the Commission for funding this and allowing us to do that, because we learned a lot. It's the best way of prototyping a methodology is to get it out there in front of the people that are actually going to be doing it. So it was incredibly helpful. So the results of that were that we did calculate the SDG and TRL for all of the trends. We found that in 65% of cases, the innovation potential, so that's the impact on the SDGs, actually was upgraded by the expert panel. So as I've said, there were a panel of experts, leading figures in a really wide range of disciplines, and in many cases they felt that the calculation of impact for a particular technology was inadequately assessed, purely looking at the SDG. So the SDG impact was interesting, was useful, but in many cases there was a higher level of oversight required because there were factors outside of the SDG that they felt were especially risky and that needed an upgrade. So we've proved that the SDGs are useful, but they're not everything. And in many cases, there were significant upgrades required. And so what we did is we introduced a new stage into the method, which is the expert peer review, and that's built into the tool as well. So when you've done your SDG impact, when you've looked at your TRL, your target TRL, you then have to do that interdisciplinary peer review and say, is there anything we've missed? Do you feel this is particularly risky? You've got to say why. You have to justify it. It's not just something that can be plucked out of the air. But we found that, in fact, in this case, it was an incredibly important stage. It didn't prove that the methodology was wrong. It just needed to be extended. So that's what we did. Again, we're very thankful to have the opportunity to try it out in the real world. So we added transdisciplinary risk assessment. So do you or your peers from a broad range of disciplines, it's up to you to define what broad means, but there's proportionality in that naturally, believe that this project or tech has the potential to pose significant risks or benefits, both, not covered by the SDGs, and that's added in. And if you do, then there is a process of upgrading how much RI you do based upon that. It's worth it, it's necessary. That's a useful thing to add. So here we are getting into organizational maturity. So what is this really all about? So it's one thing to say, here's a technology and we feel that this is very impactful and it needs a lot of oversight. But the question is, how much RI can you undertake within a project? And how much of it should be embedded in the organization in which you sit? So if you're sitting in a research organization, you will have internal processes and governance and what have you that are meant to ensure that the work that's done is legal and safe and fit for purpose and other things, and aligned with your corporate values or your organizational values and ethics, which of course do vary across industry and academia. They're not all the same. So how would we establish organizational maturity? So a paper was written some years ago on what they call responsible research and innovation maturity modeling. So papers out there in the public domain, open access. So you can see that. We looked at that and thought that seems like a really good model. Maturity modeling has come from many different areas. It's come from project management, it's come from software engineering, and from many different areas as well. And to apply it to RI seemed like a very, very natural thing. So the question is, what are all the issues that need to be addressed? Well, these are the kind of things that we're concerned about from an organizational perspective. As an organization, what do you think your role is in discrimination, in terms of, protecting identities, so privacy, things like justice, trust, fairness, all that kind of thing. We've talked about ISO 26000 and the corporate social responsibility standard, but clearly there are things like legislation that come into this, things like privacy and things with GDPR, security as well, in terms of the various security standards that are in place, things like inclusion. Some of these are covered by governance standards or legislation or other things, and others are less so. But as an organization, how many of these do we think? What's our role in ensuring that the world is a better place, or indeed not worse than it is already? So these are the kinds of issues that we wanted to consider when thinking about the organization's capability. And in many ways, you might argue the fitness of an organization to undertake high impact research. Do you feel that an organization that doesn't necessarily take the issues of justice or trust or consent or privacy terribly seriously, should they really be doing very, very high impact, high value research? I don't know. I don't know the answer to that, but it's a question that we need to ask. So these are part of this consideration. Who is well placed to undertake the most important research of our generation. So as researchers, there are various tools that we have available to us in order to affect responsible innovation, or indeed ethics by design. So you may be, if you're in academia, you have some sort of ethics approval process, I'm sure you do, about how fit for purpose is it? Is it really fit for purpose on what are some really quite complex technologies? So that's a pretty tough one. In many cases, they're not, or they're very generic, or they're seen as being a bit of a sideshow or an unpaid role. So they're not always fit for purpose. Sometimes it takes a very long time to find out that they're not, particularly for a new technology. Regulatory approval, it may be in some cases that's required, maybe more in the biomedical science area. Funding priorities is a thing as well that can be used as a tool for managing what research is done and how it's done. So, you know, and that can work both ways. You know, are we working on research which is high impact and very valuable? Are we even allowed to request funding for undertaking these more sort of ethics by design type aspects within a project? So funding priority, that's a bit of a broad church, really. It can be, is a technology fundable within our environment, but also are we actually able to ask for a percentage of the overall funding to undertake these works? The question, if they won't fund it, you can't do it. So the question is, should you even be doing the work if there's not adequate resource available to undertake proper oversight, governance, management, that kind of thing? It's a very good question and a tough one. Sometimes you don't know until later that there wasn't enough. Midstream modulation, that's more of a method about how one might change things as we go. I think we recognise that not all of this work can be done up front, because as research progresses, we discover new things that may come up, and that may require the methodology or the approach or whatever to be adjusted as we go, should the project scope allow for it. You might argue that there should be a risk provision to address unforeseen ethical concerns, but that's beyond my pay grade to suggest. That might be a way of dealing with that. Whistleblowing is another thing. So do you feel that you should blow the whistle on something, although that can have some career limiting effects, or it has done in the past? I think many people like to talk about speaking up now rather than whistleblowing, where speaking up is your voice added to, no doubt, others who have expressed concerns, but whistleblowing is the traditional term. Project termination, there are cases where projects indeed have been terminated because of RI. A project called SPICE, stratospheric particle injection, was a geoengineering project being run here in the UK, and that was actually terminated by RI, an RI process, because it was seen to be problematic in terms of opening up geoengineering modes to the general public, who may take it upon themselves to spray particles into the stratosphere to reflect incident sunlight. So pretty scary stuff. So these are the kind of things that are available to us as researchers, in theory at least. So this is taking the RI maturity modeling work that was done, and this work basically came up with 5 different levels of maturity of an organization in undertaking responsible research and innovation like activities in its day-to-day business. So at level 1, the organization is not aware of any particular RI issues, or it doesn't really talk about those, but it does comply with all relevant legislation. So it's not as if it's a lawless organization that does not follow what's required. In fact, unaware can be really quite a high level in some states where legislation is robust, and in fact unaware may be in the fullness of time quite attractive, because if our lawmakers decide to implement measures to this effect, then actually defaulting back to what is required of everybody would be quite a good thing, really. No heroics here, everybody does the same thing and it's all good. So level 1 is there's no pejorative element to this, it's all about proportionality. Level 2, where an organisation reacts to specific issues raised by a project and will actually implement things, purely reactive. So there's no proactive element. You are told that you need to look at this, and therefore you do, but only because you've been told. Defined level 3 means that, of course, you encompass all of the previous points, but that whatever you do is actually more implemented into custom and practice. It's built in within business processes already. Level 4, so it's about proactivity. So it's about really around kind of innovation. So you may have active business processes that do this, but you're also looking to apply Kaizen type principles to incrementally improve how you do these things. You take feedback from a project, for example, feed it back in, and hopefully your process gets better. So you're not only doing it well, but you're also getting it better every time, which is great. And then level 5 seeing the strategic, so it's really adopted, if not all, but certainly the majority of the RI components within an organisation across the board. So it goes beyond proactivity into something that's adopted at corporate level, and one might argue is part of the identity of an organisation. We have had some dealings with organisations like EIT Digital, for example. And one of the things they talk about is the idea of some European values in technology, and maybe that it's the thing that Europe brings to the world, but the fact that technology is developed here have maybe a higher ethical standard. Now that's quite a big claim, but it may be that something that Europe has, so it may not. We're great at innovation, not necessarily quite as good as others at commercialization or indeed the risk capital side of things, which is incredibly important and not so strong in Europe as it is elsewhere, although I'm sure that's changing with time. But it may be that actually that may be our strength, that in fact we are much more concerned about the broader implications of what we're doing than maybe others are seen to be, and we take that responsibility very seriously. Again, I'm not passing comments on this, I'm just reflecting what has been said. No comment, the positive or negative on that. But that's really the scale of organizational RI maturity that we have applied in this case. I think it's pretty robust, and again apes what's done in other sectors in software and risk and project management. Before I go on, are there any comments on that at all? I'd be happy to take any questions or your feedback on that as an approach.
So far, I don't see any comments or questions, but please feel free to put them in the questions chat.
No questions? No. Okay. Should I press on?
Yeah, I think we can move on.
Perfect. So in terms of organizational maturity, so I'll just pick up a few points here and how we've tried to interpret this. So we talk about the keys. I'm not going to argue about how many keys there are. There are a number of keys, a range of sort of 6 to 9, depending on how you look at it. But these are a number that come up regularly. So ethics is part of it. Gender equality, another part as well. Governance overall. So we talk about robust processes as well. Open access is another thing, so the fact it's the free sharing of information, so it's available. We don't want to increase divisions in society or asymmetries, so this idea of open access is key. I think they call it Plan S in some places. Public engagement is another part, so forewarning the general public or forearming with what's coming down the line. This is seen as being a very mature activity. Within public sector organisations, maybe stronger than others, industry maybe less so for intellectual property management and commercial reasons, but not always the case. And science education is another thing. So the idea is to better equip citizens with the knowledge necessary so they can participate in these debates. I have done some public engagement and science education activities on quantum technologies with a significant number of the general public, and trying to explain the relative merits and disbenefits of quantum computing to lay people is perfectly possible, but requires a particular set of communication assets in order to interpret that in a way that is meaningful. We talk about the impact of Shor's algorithm on breaking of RSA encryption, for example, which is one of the potential use cases of quantum computing. So they tell me, but what does that really mean in the real world? You know, Does that mean that all of a sudden all internet communication is readable, maybe by some, not by others, or is it just a force to encourage post-quantum cryptography to be developed? So this is the kind of challenge you have. What does it really mean, and what's the right impact? Should I be worried about it? Should I not? So this is why public engagement and science education are so incredibly valuable, but also extremely challenging to make it a meaningful two-way conversation rather than a pure broadcast with a lot of technical mumbo jumbo and gobbledygook, which is very unclear as to what its true meaning is. So I've tried it. It's very difficult, but very worthwhile, and one must continue to improve skills at doing this. So also try to fuse aspects of what we call the area framework, which is more of a process-oriented approach. So we anticipate, we reflect, we engage, and then we take action as part of an RI process. We try and build that into the research and innovation process as well. So anticipating is about looking at those broad impacts, that inter and transdisciplinarity. Reflection is about why are we doing it, not only why are we doing it, but also why are we doing it the way we're doing it. So it's also implications, but also method. Engagement, as I've said, is that broader conversation. It's got to be proportional, and it's got to be timely as well, but nevertheless engagement is crucial. We're not working in isolation. And then ultimately action. Something has to be done if action is required. So we've tried to combine these two into a set of parameters that will give an indication of organizational RI maturity, which we can then compare and contrast. So here's just an example of the kind of structured questions that we've created. Within the tool we've created, there are 8 categories. They have a varying number of questions depending on what they are. These are the kind of questions that we will ask in terms of you assessing your perception of the organization wishing to undertake research and its maturity. So here's an example. So data management plan, it would be hard to say that there wasn't one, but the question is, of course, is it sufficient? And that's a real challenge, isn't it? It's a very much a loaded question. So you're encouraged to answer these, but there are a sufficient large number of questions that you get a nice rounded result. Here's a process. I'll just take you very briefly through that. So we effectively we cover the different categories. We have different levels of questions. That data is stored centrally and used to compare and contrast to RI intensity level a little bit later in the process. But that's the overall workflow within the tool as we built it. And this is what you get. So the blue is the RI intensity level. It's calculated by combining SDG impact, risk assessment, so peer risk assessment, and technology readiness level into a number. In this case, the blue shows that the technology is at RI intensity level 5. The grey is the measured RI maturity of an organization and where there are gaps. So for example, in terms of anticipation, we see that the organization has a relatively low score in that, but the project that they're proposing to undertake requires a much higher level of anticipation because it's seen that it has a wide range of implications across many different disciplines. And so one would be required to create an action plan that would fill in that gap for this particular project. And you'd hope that if that was successful, that action plan in closing that gap, that whatever's learned there may be adopted by the organization. So ultimately the organization scores, the grey, gets better over time. So if you can see in this case, this particular organization was, by their own perception, really rather good at research ethics. So they felt that that area was particularly was adequate and nothing more was needed to be done. Other areas less so. So this is an idea of comparing organizational maturity, the grey, with the blue, which is what you think the project justifies. And then these are activities that need to be undertaken and funded within the research proposal that you are writing. So gap analysis and action plan. Go through this as quickly as I can. You've seen this one already. So we have gaps, we have where you'd like to be, where you are now, and how one might fill those gaps. So the way we do it at PREFET is we offer is the diagram. The tool will produce all these graphics for you and store all your information. We provide a range of example projects about how other people have addressed issues of anticipation effectively or otherwise, and you can then refer to those and try and create your own answer. So we keep these regularly updated, so you can go to those and say, here's a great example. Yeah, they did that really well, or maybe that's not quite applicable to my project. So that's the idea of how you might close the gap. But we leave it in the hands of the researcher to determine their particular approach. So that's the first step at filling the gap. But in terms of an action plan, the tool includes fields where you're asked questions such as, what additional activities, so over and above normal organisational, so your maturity effectively, will be undertaken by the project. So what additional activities will you do to close the gap? How long will they take? So in terms of the duration of the project, because that's an important parameter as well. What resources are needed? So you're effectively committing. You're saying this is maybe a proportion of the project budget to these activities. What particular skills might I need? And obviously ultimately costs as well, everything's rounded up to that, and what specific deliverables are to be produced. So if you have a concern, you say, yes, this is it's a great project, it's a great technology, it has huge potential value, but there are some concerns. What specific deliverables are you going to produce that effectively address how you've dealt with these issues, how you've evaluated those, and if necessarily mitigated those. So an action plan includes this, and within the tool there's a structure where you can complete these yourself, and then a report is produced and emailed to you at the end. So that's the action plan. So I'm going to start to wrap up now, and then we'll open to questions at the end. So lessons learned and actions taken. So I think I've covered some of these already. SDGs are a good gauge of innovation potential, but the expert review is absolutely crucial. Methodology is pretty hard work, which is why we built a tool, because doing it manually, as I'm sure Agatil will say, is quite a laborious process, particularly when you're in different countries trying to do this as well. How do we implement RI? So the implementation really is guided by how the tool works. So the implementation is important, hence the action plan, and then we updated the methodology to include these things as well, and these are the things we did. So just to give you an idea, we looked at candidates for tools. Should they just be a workflow? It just takes you through a process, but that looks pretty good, but it doesn't really enable follow-on research. It just leaves you, it gives you a process, but there's no element of monitoring. We look at just looking at intensity. We looked at maturity modeling as well, but it doesn't really effectively use project resources, not really. Does it improve the quality? We didn't feel so. Could it enhance deliverables? Again, probably not. It may have an impact on the organisation, not necessarily on the project. Is it something that could be exploited in its own right? We felt not. So the answer was to build all of these things into one tool. So you had elements of workflow, you had elements of assessments at the intensity level, which is to do with SDG impact and TRL. Maturity modeling, we built that as well, although that was built on some former work that was done in, I think, responsible industry, and then through RI tools and others. So many have gone before. We're standing on the shoulders of giants there, certainly. What we've tried to do is to build all these things into something that's quite practical and usable. So this is the PREFET website. I'm sure you've seen this. On top of that, we have a section called Tools, and you can access this tool for free. We really appreciate it if you did, and if you can give us your feedback on how useful it is, that would be incredibly helpful, because the tool does continue to evolve as we take feedback. So we have recently added the action plan part to this because there was some feedback that we felt we needed something a bit more structured in terms of next steps, and so we've added an action plan part, and that's going through an evaluation just now as to what should be in the action plan, but the initial feedback is good. If you do have anything that you think would make it better, clearer, or things that we've missed, we're very happy to take any comments, and we would encourage you to use the tool. I know this is a very long talk, it's quite a long presentation, wanted to share all our learnings from this, but the tool is pretty straightforward to use and you can go through it quickly. But of course, you do need to put quality information in there as well, because it's the output of this is for you to use in your project and your proposals, hopefully, and hopefully help make the world a slightly better place. So yeah, that's the once you actually go to the tool, first of all, we have the tool itself, but there's also a user guide as well, which we've written, which actually gives you a lot of design information about how the tool was built, the actual processes, screens, and all that kind of stuff. But we do want to encourage others to take this work forward and to innovate on this as far as possible. So on the principle that we want to share this information as widely as possible, it's free, it's a PDF, but I mean, if you wanted a Word document, we'd be happy to share that too. All the information's there. We'd love you to use it, and if you could make a better one, that would be even better. So there we go. And that's it, really. That's enough from me. I'm very happy to take questions, comments, criticism. That's all good. And thank you so much for your attention.
I'm looking at the question chat, and we have a question from Cecily. She's asking, will the tool be operating after the end of the PREFET project?
It will, yeah, it will. Yeah, we'll be supporting it for the duration. So yeah, the tool's not going anywhere. So it's available. Yeah, it's going to be available for as long as we can afford to support it. So hopefully forever.
Okay, I don't see any other questions. Let's wait. Maybe someone has any other idea. No, I don't see any further questions. But perhaps one more thing from also from my side, and I think that with Martin we would agree together that for us it was in PREFET, it was a really exciting but also very challenging exercise actually to connect currently existing tools that look at technology from the ethics point of view, fundamental rights, sustainability point of view, and exactly, we also, what we recognized was that the current tools, especially such as SDGs, are really looking, and I think even Martin, perhaps you would agree, that's my perception, even the ISO 26000, they really look at very specific, from a very specific point of view at sustainability, fundamental rights, and ethics, and this is not really always really a technology perspective. So it's very often a very political agenda and not really technology. So that's why it was a big challenge to connect SDG and actually add lots of interpretation from our side and trying to balance it and not overstep actually. So we are definitely in need of tools that really connect fundamental rights, ethics, sustainability, and technology. So that's something that might be worth to bring to the political agenda as well. And if I don't see any further questions, so perhaps it will be really worth to encourage you to join us tomorrow. Martin will continue. We'll continue with the training session, and tomorrow we're going to have a very exciting session also with Philip Bray. If you Martin would like to tell a little bit more and yeah, basically about the session.
Yeah. Okay. So thank you for that, Agnes. So first of all, I totally agree with you on the ISO 26000. I think one of the points there to make is that it's, you know, companies, particularly, you know, obviously it's more of a corporate thing than anything else. Companies have technology, but it's not only what they sell, but how it's sold and to whom it's sold and what goes alongside it, for example. So a lot of how technology is used is not just the technology itself, but how it's packaged up, really. And so I think some of these broader CSR issues are very relevant to this. It's not really about the tech, and that's why PAS 440 treats organizational responsible innovation differently from innovation-based responsible innovation. So I think that to put the two side by side is good. But of course, none of us yet know whether any of this is effective or not. Only time will tell. We will be lauded or damned for our inattention or lack of action or overreaction at some point in the future, as and when humanity thrives or dwindles. But yeah, that's a good point. So in terms of tomorrow's session, so it's less about method, much more tomorrow is about how the discourse about, I'm sure many of you have heard, there's so many groups, there are so many guidelines, there are so many books about artificial intelligence and about the rules and robotics and all this kind of thing. What we'll be talking about tomorrow is the fact that much of that discourse actually applies to things that don't seem quite as exciting as artificial intelligence. If you think about what AI is or may be in the future, it consists of tools and data and other things like that. Those tools and data appear in many other places in a less fully featured version, but nevertheless impact our lives right now, either knowingly or unwittingly. And therefore, some of the question is, are the things that are being recommended for AI relevant to data and data technologies more broadly, and how do they affect? So this is what tomorrow's conversation is all about. I'll be making the premise that asserting that data and data technologies and many of the things that are being asked for AI in the future are directly relevant to other technologies of a less exciting but nevertheless very important nature. Philip will be making his point about how ethics by design has been applied to AI, and then we'll bring the conversation together and we'll compare and contrast those two parts with Agatha invigilating over that conversation and bringing it back to some kind of conclusion. We'd like to think that we can conclude that conversation, although I suspect we won't. I think there's elements of veracity around both sides, but it's certainly interesting to see how much AI discourse is potentially applicable to other things that don't seem so exciting. And I'll quote T.S. Eliot, and I do on occasion, the fact that humanity doesn't end with a bang, but with a whimper. So whilst we're looking out for the red-eyed robot pursuing us, or Skynet, or whatever, the truth of the matter is that many of these things are part of our day-to-day lives, and we're not even aware of the things that may impinge upon our privacy and our personal identity and and include or exclude us, and we don't even notice them because we're so worried about the AI taking our jobs, but in fact our way of life is being impinged upon already right now, and we need to be concerned about that as well. So it's we're concerned about the bang, but bangs don't happen that often, whereas gradual encroachment in our rights and our sense of self is probably happening already, and we don't necessarily always realize it. So that's really tomorrow. Hopefully a bit more interactive as well. There are sort of two sides, or in fact three sides, and yeah, I look forward to seeing you then. And thank you very much to Agatha for very skillfully moderating this session. Thank you.
Thank you, everyone. See you tomorrow. Bye.